All right, guys, welcome to lab number 3, the scientific method and estimating. So here in front of you, I've got part A set up. And we're going to look at some unknown boxes. So I'm going to do parts 1 and 2, where I'm going to shake around the boxes for you and try to report my observations to you as clearly as possible. So here's my first box that I've got. We'll call it the purple box. And our instructions tell us to hold the box with the arrow pointing up. There is a little arrow on the side, so this is the top side of the box. And I'm going to gently move the box side to side, back and forth, and up and down. Hopefully you guys can kind of hear what's happening. So when I move it up and down, it's a fairly light box. It doesn't feel like there's a whole lot in it. I don't feel any movement. When I just move the box up and down in this method, and I move the box up and down like that. Now let's go ahead and move it side to side. And I can feel an object in the box slipping from side to side. It doesn't immediately move. It takes till I get, let's see, hasn't moved yet, lights went out. There it goes, now it moves. So it kind of sticks on one side until I get the angle of the box high enough for it to move, and then it kind of slams into the other side of the box. Okay, so let's see, let's tip it back and forth. And I can feel it moving from the front to the back of the box when I tip it. And it definitely doesn't feel like there's multiple objects in there. It feels kind of like there's one object in the box, and it kind of sticks before it moves. So I just move like this without tilting the box. I don't feel any movement in the box. So go ahead and record one or more hypotheses about the internal makeup of the box. All right, so now step 2. I'm going to go ahead and move the box in any way that I wish, upside down and sideways as well. So I've got my box. I've moved it from side to side. Now if I tip it, oops, this way and that from side to side. Feel it flopping from one side to the other, like it loses contact. It's not touching both sides of the box at the same time, the top and bottom, and it kind of moves from one side to the other. So that is the purple box, and that was orienting the box in every direction. All right, next box. Next box. All right, next box is our white box. White box, arrow pointing up. So I'm gonna go ahead and pick it up again. It feels kind of light. If I shake it from side to side. You guys hear that? Hear lots of rolling back and forth. It sounds like it's a little bit harder against the sides of the cardboard than the last box, like it's a harder object inside. And I don't feel as much change in the weight of the box when I tip it from side to side. So smaller movement inside of the box when I tip it from side to side. So when I move it back and forth this way, I actually feel a slight bit of movement when I initially move it from side to side or front to back. and it doesn't take as much of an angle to feel movement inside of the box when I tilt it from side to side or from back to back. So go ahead and record your hypotheses. And I'll do step 2 and orient the box in any direction. So let's go ahead and move the box. When I move this box in this more erratic way, upside down, I don't know if you guys can hear that or not, but I hear a metal tinging inside of the box. I definitely hear multiple different types of sounds coming inside of the box, not just the hard thing of the hard object against the plastic, or against the plastic, against the cardboard, but a metal tinging sound inside of the box as well. And it kind of goes flat, boom, boom, boom when I flip the box like that. All right, so that's our white box. Let's move on to box number 3. All right, so we got a blue box. Blue box, arrow pointing up, slightly larger than the last 2 boxes. Let's see if I zoom out a little bit. Blue box, when I tilt it from side to side, fairly light again. Heard something roll the first couple of times I moved it, and now I don't feel anything. I don't hear a whole lot of anything or feel a whole lot of anything when I just tilt the box. So it's tilting the box from side to side. Try to make your hypotheses or your observations. I'm going to tip the box upside down. Hear that? So again, side to side is pretty quiet. I don't hear a whole lot of anything. When I tip the box completely upside down, sounds almost like one of those rain sticks. There's little objects in there moving around, and one maybe slightly larger object in here bonking around. All right, go ahead and record your observations and hypotheses given the new circumstances. All right, next box, our yellow box. Yellow box, arrow up. I'm going to tilt it from side to side. Again, fairly light. All of our boxes have been pretty light so far. Go ahead and tilt it from side to side, or move it back and forth. Side to side, don't really hear anything. Oh, there we go. Something kind of clinked against the edge. When I tip the box from side to side, oh, there it goes. It is moving. So it definitely takes pretty good tilt to the box before whatever's inside of it moves. And it kind of moves with a sudden clunk. It makes the object feel a little bit bigger than some of the other objects. So when I get about here, it finally goes and moves against the side of the box. All right, record your observations and make your hypotheses. All right, now I'm going to turn the box upside down. Can you hear that? Or kind of a thud. mud when I move it and I tip it. You can kind of hear it going back and forth inside of the box. All right, that's our yellow box. One more box. Next box is our pink box. Arrow pointed up. Ooh, this box is a little bit heavier than the last 4 boxes. All right, let's go ahead and tilt it side to side. And I move it. I don't feel much movement when I feel a little bit of movement when I get the angle a little bit higher like that, but it just feels like a little short, sudden movement. So it feels like something is just moving a little bit when I get the angle up high enough. Now let me do front to back. Oh, there it goes. So when I do it front to back, I feel like I get a larger movement, like something's rolling across the entire length of the box or sliding across the entire length of the box. But when I go right to left, there's a slight bit of movement inside of the box, but it's not nearly as much. I don't feel as much movement from left to right as I do from front to back. Oops. All right, go ahead, record your observations and form your hypotheses. All right, now I'm going to go ahead and flip the box upside down and twirl it all around. All right. Oh. So one side to the other. Oh, you can feel whatever's in there. When I flip it from what was this face to this face, I feel kind of a big movement. I feel something inside of it bouncing. All right, now let's see what happens when I flip it from this face to this face. You guys can see my video all right. So this face to this face. I still feel a big movement. And feel something bouncing in the box. Now when I tilt it this way where I didn't feel much movement, I feel lots of movement. Maybe it was stuck. Oh, there it goes. Now I'm tilting it left to right again. I don't feel much movement until I make it a bigger movement. This front to back tilting, whether I did it big or smaller, I kind of felt that movement and that bouncing feeling. All right, that is the end of part A, and that's the end of our boxes. All right, here we go. Lab number 3, part B, unknown liquids, and we're gonna do part 1 here. So we're gonna mix liquids. We've got 4 unknown liquids in front of us, and I've taken a sample out of each unknown bottle and put it into a smaller container for my own use with little plastic pipettes for divvying up my samples. So I've got unknown 1, 2, 3, and 4 in front of me, along with water. So what I'm gonna do is I'm gonna mix each one of the liquids with each other and with water. So I'm gonna mix liquid 1 with liquid 2, liquid 1 with liquid 3, 1, 4, 1, and water, and so on and so forth until I have mixed every conceivable combination with each other. So what I've got here is I've got a nice little list to help me keep track of what is in what, and I've got the test tubes labeled as tube 1, 2, 3, 4, so on and so forth, and what my mixture is in it. So my first test tube is going to be a mix of 1 and 2. Test tube number 2 is going to be a mix of 1 and 3, and so on and so forth on down the line. So what I've got here is I've got my first 4 test tubes. I've got test tubes 1, 2, 3 and 4. If you can see that, I've got it written on each test tube with a little bit of Sharpie to help myself stay organized and not get confused on what test tube has what in it. All right, so my first 4 test tubes all get unknown number 1 in it. So I'm gonna go ahead and add about a half a milliliter of test tube, or unknown number 1, to my first 4 test tubes. So there goes test tube number 1. Two. I just did 2, right? No. 3. And test tube number 4. Okay. So I just got that started. Now I'm going to go ahead and add unknown number 2 to test tube number 1 and observe. All right. Unknowns number 1 and 2 have been mixed together in test tube number 1. I'm going to give them a flick, and that's how you properly mix 2 unknowns or 2 things together in a test tube. You kind of flick them, you don't violently shake, you never put your thumb over the top and give it a good shake. That's not how that works. You'll get this stuff on your skin. Not that all of it will be harmful, but it could be, so you don't want to do that. So let's take a look at this. Unknowns number 1 and 2 are mixed together, and if you guys can see that there, you can see I've got 2 distinct layers in unknowns 1 and 2 when they mix together. So they don't mix together, I suppose. So when they're put into the same test tube, unknowns 1 and 2 do not mix together. They're both clear and colorless. I don't see any gas bubbles or any precipitates formed, but I do have 2 separate layers. Unknowns 1 and 2 are not miscible with one another. They do not dissolve in one another. All right, so that was test tube number 1. Let's move on to test tube number 2. So unknowns 1 and 3. So unknown 1, take my sample of unknown 3. I'm gonna go ahead and put it in test tube number 2. So unknowns 1 and 3, give it a little tap, try to mix it together. I don't wanna flick it too hard, cause any splashing. Unknowns 1 and 3. So again, unknowns 1 and 3 do not mix together. They form 2 separate layers that you can see there. Focus in, there we go, 2 separate layers for unknowns 1 and 3 in test tube number 2. All right, next up, test tubes. Or test tube 3 with unknowns 1 and unknown 3. 4, sorry, that's a big lie. Unknown 4. All right, so 1 and 4, even without tapping, unknowns 1 and 4 have formed a single uniform solution. We don't see any distinct layers. It's clear and colorless. There's no precipitates or anything being formed. Nothing coming out of solution. And we've got, and I don't have any evidence of bubbles or gas evolution. Okay, so that was test tube number 3. Test tube number 3 with unknowns 1 and 4. All right, test tube number 4, unknowns 1 and water. Make sure I tick that off so I don't get myself confused. All right, so I've got unknown 1 in, and I'm going to add water. All right. Oops, let's get in front of the camera. So go ahead and give a flick, try to mix them together. Unknown 1 and water do not seem to mix together. I've got 2 distinct layers, one on top of the other, and you can see that. See that layer in the middle between the 2. no precipitates or bubbles. So that is test tube number 4 with unknown number 1 and water. All right, so now we're gonna do, let's see, I'm gonna do test tubes 5, 6, and 7. I'm gonna put a sample of 2 in the next 3 test tubes. So 3 more test tubes. Get my rack out of the way. So I'm gonna have a test tube 5. A test tube 6. And 7. So labeling things and keeping a nice, neat, clean workspace, organized, clean workspace is always super important for keeping track of all this stuff. So you don't have to go through and redo labs because nobody wants to do that. That's not fun. All right, so for test tubes 5 and 6, I'm gonna mix 2 and 3, 2 and 4, and 2 and water. So I'm gonna go ahead and add some of unknown number 2 to all 3 of these test tubes that I just labeled. So there goes 2 into 5, 2 into 6, and unknown 2 into 7. All right, so now I'm gonna go ahead and add unknown number 3 to test tube number 5. So this is mixing test unknowns 2 and 3 together. So unknowns 2 and 3. So when I take a look at unknowns 2 and 3, they seem to form a single solution. There's no bubbles, there's no precipitate, there is no distinct line between the 2 layers. So they appear to dissolve in one another and form, and would therefore be called miscible with one another, or soluble in one another. All right, so that was test tube number 5. Let's do test tube number 6. Test tube number 6 is going to be unknown 2 and unknown 4. Again, unknowns 2 and 4. So you can see what's going on in there. Kind of see a little bit of a shimmer in it, like an oil-like shimmer. Kind of give it a second and see what happens here. Doesn't help the lights keep going off on me. So unknowns 2 and 4 seem, oh, let's see. Let's turn the lights back on. All right. I think it's harder to see. So unknowns 2 and 4 seem to form a solution and are soluble. That was test tube number 6. All right, test tube number 7 will be unknown 2 and water. So test tube 7, unknown 2 and water instantly form a solution and have no problem mixing together. All right, test tubes 8 and 9. So test tube 8 is going to be unknowns 3 and 4. Test tube 9 is going to be unknown 3 and water. Go ahead and put unknown 3 into both test tubes 8 and 9. Unknown 3 into test tube 8. Unknown 3 into test tube 9. All right, so unknown 3 gets a little dash of unknown 4 into test tube 8. Let's observe what happens. Oh, look at that. Mix it up. We've got white layer being formed. Definitely got what we would call a precipitate, or something that comes out of solution. It's not soluble in the liquid it's in anymore. So you guys can see that. Unknowns 3 and 4 create a precipitate. So a substance comes out of solution. That was test tube number 8. All right, test tube number 9 is unknown number 3 and water. Test tube 9, unknown number 3. Let's add some water. Let's see what happens. All right, so as unknown 3 and water didn't form a precipitate, no evidence of gas bubbles, and no layering, so they mixed together. So it's test tube number 9. All right, last test tube number 10 is going to be unknown number 4 and water. Unknown number 4 into the test tube and water. And this should be all of our possible combinations. All right. That is test tube number 10, which was unknown 4 and water. Looks like there's one single layer. And that was all of our combinations. So go ahead and make your observations for that part. All right, guys, we are on part B, unknown liquids, and we're going to test for pH. So in front of you, I've got each one of our unknowns, 1, 2, 3, and 4 in front of you. And I've got 4 pieces of litmus paper. So I'm going to go ahead and drop the liquid onto each piece of the litmus paper, and then compare it to the scale on the tube to test the pH of each one of our unknowns. So here goes unknown number 1. Unknown number 2. Unknown number 3, and the color changes on the strips will indicate the pH. And unknown number 4. Unknown number 1 looks like it kind of dried up already. Let's do that again real quick. All right, so I will pick this up so you can see it better. So unknown number 1. Should be able to get a reading off the pH on that. And what do you think it's closest to? That's unknown number 1. Unknown number 2. Let's see, looks like it's more in that realm. Looks like it's got a pretty low pH. I'd say it looks closest to 1. The color's a little hard to see. So I'd say it looks like about a 1.0. Let's read you number 3 real quick as well. Come here. Unknown number 3. Let's see. No, not a 7. It's not quite that green. All right, I would say that looks pretty close to a 6. Let's go ahead and look at unknown number 4. Turn the scale because it's definitely more greenish blue. Say it looks pretty close to that 9, maybe somewhere in between the 8 and the 9. All right, that is our pH test for our unknowns. pH, let's go ahead and look at the pH of tap water. Get my strip out. All right, dot the strip. That's weird. Let's try another one. Okay. All right, go ahead and look at the pH of water. Okay, so that is our pH of water, of tap water. So you can see the number. All right, we're gonna go ahead and test the flammability of our unknowns. Be ready to record your results. So first up, I'll put unknown 1. A couple drops of unknown 1 here on the watch glass. Take a match. All right, let's look at unknown number 2. A couple of drops. My match went out when I got it close to the liquid. It is not flammable at all with a match. All right, let's try unknown number 3. That was unknown number 3. Let's look at unknown number 4. That was a good match. One more go. Match goes out when I get it close to the liquid or when I touch the liquid. Just puts it right out. So unknown number 4 is not flammable with a match either. So let's take a look at 2 and 4 again. Lab report, the write-up says if they're not flammable with a match, can we ignite it with a Bunsen burner? So let's get a Bunsen burner going. Bunsen burner going to a reasonable flame. Back these up. All right, unknown number 2. Bunsen burner. Doesn't ignite it. Unknown number 4. Make my Bunsen burner. Doesn't ignite it. Take a look at the evaporation / surface tension, and we're going to place a few drops of each one of our unknowns onto the countertop and watch them evaporate, and whether or not they spread out or kind of stay in a tight little grouping in the puddle. So here's unknown number 1. Kind of see that spreading out, moving around the countertop. See what it does as we look at unknown number 2 next to it. Unknown number 2 doesn't spread out as much. It stays in kind of a little bubble, I suppose. Unknown number 3. And unknown number 4. All right, there's your 4 unknowns. Watch them for a few minutes. You can see unknown number 1 is pretty much dried up and gone. Unknown number 2 hasn't changed a whole heck of a lot. Unknown 3 is spread out all over and is drying up slowly. Unknown number 4 looks a whole lot like unknown number 2 does. Alright guys, we've got unknown number 1 set up to find the boiling point of unknown number 1. I've got a thermometer suspended in our liquid, turning the hot plate on, and slowly turning the hot plate on, and I've got my thermometer suspended in my liquid. I've got it so it's submerged in the liquid, but not touching the bottom. Oops. Touching the bottom. So we're gonna go ahead and watch this boil so we can see, measure the boiling point. So this is unknown number 1. Watching for the first sign of bubbles or the boiling point. Now, unknown number 1. Let's see. See it kind of starting to shimmer and move around. See the temperature going up. We're at over 40 degrees Celsius, approaching 45. Over 50 now. Oh, I see some bubbles starting. Let's see where we're at. We're at 60. We're still moving quickly. Turn the temperature down. All right, we are at 66, I'm gonna say 66.0 degrees Celsius for the boiling point of unknown 1. Switch out unknowns. Remove unknown 1 off the side, let that cool down. So I can get a sample of unknown 2. Bring up my thermometer. Alright, unknown number 2. Down lower. Thermometer back down to the unknown number 2, so it's not touching the bottom, but it's fully submerged in my liquid. That looks pretty good. All right, so this is unknown number 2. Turn the hot plate back on. While we watch that, I'm gonna go ahead and dispose of unknown number 1 in the proper waste container. All right, the temperature is slowly climbing on unknown number 2. I don't want the hot plate cranked up too high. We're at about 45 degrees Celsius right now. And this is unknown number 2. We're at about 55 degrees Celsius. Approximately 60 degrees Celsius. 70. Oh, I see some action starting. Some little bubbles starting to form. Turn my hot plate down just a little bit so we don't fly past. It's a small volume we're heating. Where we're at. We're at about 80, 82 maybe degrees Celsius. Steadily climbing still. 85 to 90 mark. Looks like we've got action there. We've got definitely are boiling. And we are at 94 point, let me double check. Let's see, 90, let's see. I'm gonna say that was 96.8 degrees Celsius for that boiling point of unknown 2. All right, let's take a look at unknown number 3. Uh-oh. So what we've got going on here is the hot plate was still hot from unknown number 2. So as soon as I set it on there, unknown number 3 is starting to boil. Without even adding heat. So I'm going to go ahead and remove that and try this one again because that's not going to be an accurate reading. Let this hot plate cool down. We have unknown number 3 back on the hot plate for go number 2 at its boiling point. to almost 65 degrees Celsius. Now let's watch for some bubbles. Again, this is unknown number 3. I'm starting to see some bubbles form. Let's see, we're at, I'm gonna say 73.2. This formation of bubbles indicates boiling, and we're gonna call that boiling point 73.2 degrees Celsius for unknown number 3. Last but not least, unknown number 4. All right, so this is unknown number 4. Got the hot plate on, in place. Let's watch for bubbles. You can also make some correlations between the boiling points and that surface tension we watched earlier. And we put each of the unknowns onto the laptop and watched it. Whether it formed a bubble, whether it spread out, whether it evaporated, and so on and so forth. Temperature is roughly 45 degrees Celsius right now. bubbles rolling. We are definitely boiling. And our boiling point is roughly 93.2 degrees Celsius for unknown 4. All right, last but not least, we are going to do part C, estimating. So we've got a clear plastic quart jar filled with some dried beans. These would be our dried beans, and it's labeled. The mass of the beans and the jar weighs 922.3 grams. So I'm going to take some different measurements for you. You can use volume or you can use mass to be able to figure out how many beans are in the jar. So let's see, I'm going to take a few different measurements for you. And we've got extra beans that we'll take some measurements of those beans for you as well. All right, so let's look at this jar. I'm gonna get, let's see, I'm gonna go around all the way around the middle. Get a circumference of the jar. I get a circumference of the jar. Come here. To be 31, we're just over 31 centimeters. I'm gonna say it's about 31.6 centimeters for the circumference of the jar. 31.6 centimeters. All right, let's look at the height of this jar. So from the top to the bottom. Take the height of the jar. Let's see, we're at about, let's see, right close to 16 and a half. So just shy of that. Just shy of that is 16, let's go 16.49, the height of the jar. That center because I think I wrote it down wrong. I don't know if you guys could hear that recording, but my phone wanted to talk to me about whatever I was saying. All right. Yes, I wrote this down wrong. I forgot a digit. There we go, 31.06 centimeters is what I meant. Okay. Let's see, what else can we measure? We've got a circumference, we've got a height, we can get a diameter from the circumference, we've got a radius from the circumference. We got the height of the jar. I think that's pretty good for some volume of the jar measurements. So let's get some volume, an average volume of the beans. So I'm gonna do the average volume of the beans, similar to how we did our stuffers. I'm gonna use a 10 milliliter graduated cylinder. The beans are small, they're not gonna move the water much, so I don't want a big graduated cylinder, like 100 milliliter. It'll be a tiny little bit of movement. It'll be easier to see on here. All right, so I'll do, let's see, I will do the volume of 5 beans. So I've got 5 beans that are very representative of the sample. All right, so my volume measurements. So my initial volume that I'm starting with here, where I can see it at the bottom of my meniscus. I've got .4 for certain, and I'm going to estimate 3.43 for my initial volume before I've added any, 3.43 milliliters, excuse me. 3.43 milliliters for my initial volume before I have put in any beans to the jar. So 3.43 milliliters. All right, let's add in a bean. right, my next volume is 3.72. So volume with one bean in there is 3.72 milliliters. Let's add another bean. All right, that put us up just over 4. Just barely over 4, so I would say 4.03 milliliters. So my next bean, let's add another bean. Let it settle for a second. We're up to 4.3, almost to that 4.4 mark. So I'm going to say 4.38 milliliters. One more bean. All right, we're definitely at that 4. Let's see, we're at just above 4.7. 4.7 for certain. Estimate my last digit. 4.7. 4.72 milliliters. And volume 5. The last bean. The final volume is going to be just over that 5. 5.01 milliliters for that final volume. Okay, so that is going to be my way of measuring with volume. Now I'm going to go take some masses. We got the mass of the jar, the mass of the beans in the jar. And I'm going to go take the mass of some beans for you using the analytical balance like we did the other day. I'm just going to go ahead and add those masses into a data table for you, and then you can go ahead and show your calculations in your lab report of how you're going to estimate the number of the beans in the jar.